Hi, welcome back. Today we have a question which is a solid sphere with a diameter of 18 centimeter float in 20 degrees Celsius soft water with 1527 centimeter cubic exposed above the surface. Alright, so we have the sphere. And on top of this is submerged into the water. Alright, for this case, this solid sphere floating in the water. Alright, this part actually exposed of 1527 centimeter cubic. So what's the weight and the specific gravity of the sphere? Alright, so first we need to draw the free body diagram. Okay, so here we have the weight of the solid sphere, which is acting downward, right, due to the gravity, as well as we have the buoyancy force Fb. So in order to get the weight of the sphere, alright, we use the summation of force as the free body diagram. Summation of force in the y direction equal to 0 because this is considered as equilibrium. Alright, so downward, okay, first positive. FB pointing upwards, it is positive. And WS pointing downward, it is negative. WS equal to 0. So in order to get the WS, rearrange, we get the WS equal to buoyancy force. So how to calculate the buoyancy force? The buoyancy force, the equation is gamma of fluid multiplied with the volume of displaced fluid. Alright, so what is the displaced one? This is the displaced volume. So we need to have only this displaced volume because this object displays this much of the volume. So this is actually the buoyancy force. Alright, so from here, the fluid, okay, the fluid of the water, which is, consider this is the water, standard water, which is 9810 multiply with the volume. So how to get this volume? So because we know already this exposed volume is this value. So you need to calculate the whole of the total volume of the sphere, which is 4/3 pi r cube. So the radius here, is diameter divided with 2, which is 18 centimeter divided with 2, which is 9, okay, centimeter convert into meter, which is 0.09 meter. Okay. Okay. So once you get the radius, okay, just substitute into this equation. 4/3 pi r cube, so multiply with 0.09 cubic. Okay, and then you need to minus, this is the whole bracket, with the exposed one, which is 1527 centimeter cubic, convert into SI unit. So 1527 centimeter cubic convert into meter cubic, you need to divide with 103 times. Okay, so 1 2 1 2 1 2. So point here 0 0. Okay, so 0.001527. All right. So this is the volume that you're going to calculate. Okay, so end up you will get your answer to be, okay, 14, okay, 0.911 Newton. Alright, so once you get this value, around this value, okay, and then you need to find the specific gravity. So the specific gravity is equal to density of the sphere over density of water. So density of water we know already 1000. So you need to find the density of sphere, which is density of sphere is equal to the weight over, okay, sorry, the density of the sphere, okay, is equal to mass over volume. We know already mass equal to, or we can say that the weight equal to mass multiplied with gravity. And the mass is equal to weight over gravity. So replace this mass with the weight over gravity in this part. So you will get density of the sphere equal to the weight over gravity volume. Okay. So after that, okay, just substitute the weight that you discover, this one, which is 14.911 Newton, divide with the gravity 9.81, and divide with the total volume. Okay, so the total volume of the sphere, which is, okay, here 4/3 pi r cubic. So 4/3 pi r is 0.09 cubic. And finally, you will get your final answer to be the, okay, the density of the sphere to be 499 kilogram per meter cubic. So the specific gravity is the density of the sphere, which is 499 divided with 1000. So you will end up around 0.5. Okay, so that is the specific gravity of the sphere that we discovered, okay, just now, as well as the weight. Alright, so the next question asks, will this same sphere float in a gasoline having the density of 680 kilogram per meter cubic? If so, what volume of the sphere will it expose? Okay, so for this part, okay, let's compare the density of the gas, the density of the gasoline, which is 680. So for part B, we compare the density of the gasoline, which is 680 kilogram per meter cubic, while the density of the sphere, which is 499 kilogram per meter cubic. So you can see that the density of the gas is much more bigger than the density of the sphere. That means this is float or not. So that means the sphere will definitely float. Okay. Because the density of the sphere is lower than the gas. So it will float. Alright. So for this case, how to get the exposed volume? We're going to use the ratio. Alright. If so, what volume? If so means it is float. Alright. So what volume of the sphere will it expose? Okay, once floating, the question asks what's the new exposed volume. Alright. So we're going to use the ratio of the density of the sphere over the density of the gas, which is 499 divided with 680 equal to 0.733. So this reflects to the 73.3% of submerged. Okay, so for example, this is the sphere. Only this portion 73.3% submerged. And this portion refer to the 100 minus 73.3%. So, based on this percentage that we're going to discover, which is 26.6%. Okay, 0.266%. Alright, this is coefficient, this is percentage. We need to multiply with the whole of this volume, which is 4 over 3 pi r cubic, which is 0.09 cubic, because this is the radius. Okay, you can see this, the radius, 0.09 meter cubic. So finally, you will get your solution to be, okay, 0.09 cubic multiply with the pi, multiply with the 4 over 3, multiply with 0.266. So your final answer to be 8.123 multiply with 10 the power of negative 4 meter cubic. That is the final answer to get the exposed volume here. So this volume will have 8.123 multiplied with 10 the power of negative 4 meter cubic, or you can directly convert into centimeter cubic. Just multiply with 103 times. You will get 812.3 centimeter cubic. Okay, let's compare. This one is a lot bigger, volume 1500. This is only 800. Okay, that's it. Therefore, that is the final answer.